Hi, Assalamualaikum. My name is Muhammad Ali Hakimi bin Shamuddin. I'm introduced about hydroxypyruvic acid. For the background, hydroxypyruvic acid is an important intermediate in amino acid metabolism, especially in the conversion of serine and glycine. It is naturally produced in human tissues such as the liver and kidneys, where it participates in the glycosylase and decarboxylase metabolism pathways. This compound is formed during enzymatic reaction, including the oxidation of glycerate and the transamination or deamination of serine. Next, UPAC name. The compound UPAC name is 2-hydroxy-3-oxopropanoic acid, and it is commonly referred to as hydroxypyruvic acid. Next, functional group and structure. Hydroxypyruvic acid contains multiple functional groups: a carboxylic acid COOH, a hydroxy group OH, and a ketone C double bond O. This group contribute to its chemical activity and biological role. Next, the homologous series. The compound belongs to both the hydroxy acid and alpha keto acid homologous series. It is structurally similar to pyruvic acid, different by the addition of a hydroxy group. For the last, structure formula. This is structure formula for hydroxypyruvic acid. Carbon 1 attached to OH group. This is a hydroxy methyl group, and carbon 2 has a ketone group. This is a carbonic carbon. Carbon 3 is part of carboxylic acid group.
Assalamualaikum. My name is Nuri Nazha. So I will present about the uses of hydropyruvic acid. So the first one is chemical intermediate, used in the synthesis of keto acids, amino acids, and other biologically relevant compounds. The second one is biochemical research, applied as a model compound in studies related to oxidation reduction reactions and metabolic pathways. The third one is catalyst or substrate, functions as a substrate in enzymatic reactions for educational and experimental purposes. The next one is biomarker development, investigated as a biomarker for dietary intake or metabolic disorder. And the last one is food component detections, occurs in a variety of edible plants, making it as a natural indicator of certain food consumptions. Next, I would like to show to you guys about the benefits of hydropyruvic acids to humans, helps in diagnosing and monitoring metabolic diseases, naturally found in foods, non-toxic, and safe in trace dietary amounts, potential for use in metabolic therapy and clinical nutrition, and it's also involved in neurological function due to glycine linkage. The second one is to living organism. It's naturally integrated into biological cycles in microbes and plants. It also participates in plants' metabolism and may influence plant growth and defense. And the last one is it's also served as a nutrients indicator in ecological studies of plant-eating organisms. Moreover, to the environment, it can be synthesized from renewable sources like glycerol, a biodiesel byproduct. It also supports green chemistry principles by reducing waste and improving sustainability, and It's also biodegradable, which does not contribute to long-term chemical pollution. Last but not least is the benefits of hydropyruvic acid to the industries. It's valuable in pharmaceutical manufacturing as a precursor or intermediate, supports by refinery concepts through conversions from biodiesel waste. It's also used in analytical chemistry, metabolic profiling, and nutraceutical development. And it could be involved in cosmetic or food additive development in the future. That's all from me. Thank you.
Hi, my name is Wesley. So now, as for the physical and chemical properties of hydroxypyruvic acid, it exists as a sweet state, as a white and pale beige powdery crystalline. It also has a melting point and boiling point of roughly around 82.4 degrees Celsius and 257 degrees Celsius. Hydroxypyruvic acid has a life shelf up to 12 months or longer if it stores properly, and it is recommended to store it in a tight sealed container to avoid from the moisture and contamination within the air.
Let's take a look at the reaction shown on this slide. This is an oxidation reaction involving 3-hydroxy 2-oxopropanoic acid, also known as a hydropyruvic acid, which is oxidized using a potassium permanganate. Here on the left, we have a 3-hydroxy 2-oxopropanoic acid. Notice it has 3 important functional groups: a hydroxyl group on the carbon 3, a ketone group on the carbon 2, and the carboxylic acid group at the end. When we treat this compound with a Chm301 H+, which is a strong oxidizing agent, it acts specifically on the hydroxyl group. The hydroxyl group is oxidized to a carboxylic acid, forming an oxopropanoic acid. Now we have 2 carboxylic acid groups, one at each end, and the ketone group in the center remain unchanged. Let's explore a chemical transformation, unlike the previous oxidation reaction. This one involving reactions specifically using a Wolff-Kishner method. This molecule, carboxylic acid at one end, and ketone at the carbon 2, and the hydroxyl group on the carbon 3. The ketone here is the target for this reduction. When treated with the hydrazine in concentrated potassium hydroxide, the ketone undergoes complete reduction. This is a 2-step process where the ketone first forms a hydrogen intermediate, then is fully reduced to a CH2 group with the release of nitrogen gas and water. The result is 3-hydroxypropanoic acid, a simplified version of the original molecule with the ketone group removed. The hydroxy and carboxylic acid group are retained, but the central carbon is now fully saturated. Now, let's move on to multi-step transformation starting from 3-hydroxy to oxopropanoic acid. This reaction showcases how a carboxylic acid can be as reactive reduced to an aldehyde. Here we begin with 3-hydroxy 2-oxopropanoic acid, which contains 3 key functional groups: a carboxylic acid, a ketone on the carbon 2, and the hydroxy group on the carbon 3. In the presence of COCl2 and pyridine, the carboxylic acid is converted into an acid chloride, forming a 3-hydroxy 2-oxopropanoic chloride. This transformation activates the acid for selective reduction. The next step involves selective reduction using a bulky reagent, lithium tritium butox aluminum hydride. This mild reducing agent is specifically used to reduce acid chloride to aldehyde without affecting other carbonyl groups. As a result, we obtain 3-hydroxy 2-oxopropanol. The acid group has been converted into an aldehyde, while the ketone and hydroxy group are preserved. This method is especially valuable when the precise reduction is needed in a complex molecules. Alright, to conclude my presentation, I would like to highlight the significance of hydropyruvic acid. This compound, also known as a 2-hydroxy 3-oxopropanoic acid, play an important role in the amino acid metabolism, especially in the conversion of serine and glycine. is naturally produced in our body, mainly in the liver and kidney, and it can also be found in certain plants and food resources, make it non-toxic in a small amounts. Because of its role in the metabolism, hydropyruvic acid is useful in the medical studies, especially for monitoring metabolic disease. It may also be involved in neurological function due to its connection with blood signs. Beyond that, it's applied in the research related to the oxidation reduction reaction and serve as a building block for biologically important compounds like amino acid and alpha ketone acid. In short, hydropyruvic acid is a small but powerful compound with the important roles in both health and science. Thank you.